Yes. Hello students, welcome to Gradeup, India's largest online platform for GATE, ES and PSUs for other competitive exams. Students, all of you, very good evening. Welcome to the session. Continuation of electrical missions. I am discussing the different models of questions on DC missions. With respect to DC mission series, this is the last concept with respect to DC mission students. Today I am going to discussing different models of questions based on testing and special cases of DC missions. Testings and special cases of DC missions. Yes students, all of you very good evening. Welcome to the session students. Saujanya, good evening. Welcome to the session. Yes students. Before starting the today topic, first let me introduce myself. Students, my name is Surendra Babu. For 10 years, I am educating the students for GATE, ES and PSUs in electrical and electronics engineering. Students, these are the subjects I am teaching for various competitive exams: network theory, power electronics, electrical missions, yes, power systems, electrical and electronic measurements, transducers and mechanical instrumentation. Yes, students, all of you, very good evening. Welcome to the session. Yes, students. Students, all of you concentrate. Renuka Yadav, good evening. Welcome to the session. Students, this is our Gradeup Super. Who are the aspirants for GATE, ESC and PSUs? For structured course, subscribe for Gradeup Super students. There is a vision 2020 to 2022 in English language for GATE, ES and PSUs. It is in Hindi language for GATE, ES and PSUs. There is a vision 2023 that is also there in Hindi and English language students. To get unlimited access to your preferred courses, subscribe to Gradeup Super. For more information, contact this number students. Yes friends, this is one announcement. There is a flat 50% off on Gradeup Super for GATE, ESC and PSUs. Use the code of Mission50, get the 50% off students. Kanchi Uma, good evening. Welcome to the session. Yes. Students, these are our star faculty in electrical, Gradeup faculty. You please go through the lectures of all our star faculty in app classes and also in YouTube classes. This is my Telegram channel. Who are the aspirants for GATE, ES and PSUs? For more updates about my lectures and you have any doubts clarification, you please join this channel students. Yes friends, I am starting the questions based on the today topic, that is the testings and special cases of DC missions. Some important models of questions I am going to solve. Very important students, please concentrate. Yes, here the first question is displaying. Can anybody answer this question students? These are the questions based on different special cases of DC missions and also some testings. Based on the testings also I am solving the questions. Yes, all of you very good evening students. All of you welcome to the session. All of you welcome to the session. Yes, all of you like the session, share the session students. Welcome to the session. Yes. Here the first question is displaying. Can anybody answer this question students? Come on. A DC series motor is accidentally connected to single phase AC supply. The torque produced will be dash. That is, actually it is a DC series motor. It is connected to the AC supply. The torque produced will be dash. What is the torque produced? This very simple students. Very simple question this one. You please concentrate. We know that given is series motor. Given is series motor. Then how to answer this question students? Please concentrate. In series motor, all of you well know this one. Already given in the previous lectures also, friends. Yes, Arjun, welcome to the session. Good evening. In series motor, torque is proportional to pi Ia. That you know that torque is proportional to Ia square. Yes, friends. Given that if supply is AC, if the supply is AC, then you know this bidirectional supply, alternating supply. Let this is current. Let this is the armature current. Then we can square this one. If you do the IA square, students, this negative becomes positive. If you square this one, what this negative becomes, friends? We can get the positive. This is IA we can get. Yes, friends. This IA square means negative becomes positive. Once the negative becomes positive means it is a unidirectional current. Unidirectional current. Yes, friends, please concentrate. Unidirectional current. Because of unidirectional current, the torque is also unidirectional. Torque is also unidirectional. Torque also unidirectional. Please concentrate, friends. Torque also unidirectional. The torque also unidirectional. But it is not a constant DC. It is not. If it is a constant DC, there is no any pulsating torque. But it is a pulsating. It is a pulsating. Pulsating. That's why torque is also pulsating. That's why which option is correct, friends? Which option is correct? The pulsating, and it is a unidirectional torque. Very good, Sauchanya. Option D is correct. It is a pulsating unidirectional torque. Because torque is proportional to Ia square, and even though it is the AC supply, this negative becomes positive because of square torque. Because of square torque, then it is a unidirectional current. That's why unidirectional torque. Torque also unidirectional. But it is a current is pulsating nature. That's why pulsating torque, and it is a unidirectional torque. Yes, Arjun. Yes. I will plan. According to your requirement, I will plan, Arjun. No problem. Yes. Okay, Arjun. Thank you. Yes. Yes, friends. Very good. Option. Arjun, yes. Option D is correct. Saujanya, option D. Yes, very good. Option D is correct. Yeah. One more question, students. Will you please concentrate, all of you? A 400 volts, 25 kilowatt, 450 RPM DC shunt motor is braked by plugging when running on full load. Determine the braking resistance necessary if the maximum braking current is not to exceed twice the full load current. Take armature resistance as 0.2 ohms. Yeah, this is the question based on the braking. What type of braking this one? Plugging. Based on the plugging, here I am solving the question. Yeah, this model already framed in gate exam also. Already framed. You please concentrate, students. Yeah. This is the question based on the plugging. You want to find what is the braking resistance. Students, how to do the plugging? Reversing the armature terminals. The plugging is applied by reversing the armature terminals. Once you can reverse the armature terminals means this formula you know. Here I am not explaining total concept. It is not required. Yes, friends. Please concentrate. What are the braking currents, friends? In plugging, that is V and EB is opposing. V and EB is opposing. Then what are the braking current? The braking current IB equal to, it is not V minus EB, it is V plus EB. It is V plus EB by RA plus RB. Yeah, this formula you know. What is IB, students? Braking current. With respect to plugging, yeah, this is the braking current. Yes, what is RB, students? Braking resistance. You want to find the braking current, not you find the braking resistance. This you want to find. Braking resistance you want to find. Yeah, this is the braking resistance. Yeah, this you want to find. To find this one, first I want to know the what is full load current. Given is 400 volts, 25 kilowatt motor. 25 kilowatt motor. Then what is the load current, friends? This IL equal to 25 into, that is 25,000. 25 kilowatts, that is 25 into 10 cube by 400. 25 into 10 cube by 400. Yeah, this is how much we can get, friends. This we can get 62.5 amperes. We can 62.5 amperes. Is it okay, students? This we are getting 60. But here shunt resistance is not given. In a motor, that you know that in motor Ia equal to ISH plus, sorry, a motor, it is a motor, we are giving the supply. Okay, this is motor, input current we are giving. I have taken as I. Instead of IL, I taken as I. Yes, friends. What is I equal to? ISH plus IA. The total input current equal to ISH plus IA. But RSH is not given. That's why you neglect this one. You don't have any data to find ISH. Neglect that one. What is I equal, students? IA. Yeah, this is I equal to IA equal to how much this one? 62.5 amperes. What is the condition is given? Braking current is equal to how many times, students? The braking current is equal to twice the full load current. Twice the full load current. 2 times of 62.5. Yes, 2 into 62.5 is equal to, yeah, before that I want to calculate EB. I want to calculate the EB, students. Then what is EB? EB equal to V minus IA into RE. What is V, students? It is 400 minus IA is 62.5. RA is how much it is given, students? RA is how much it is given? 0.2 ohms. Can anybody tell what the back EMF you can get? Quick. What the back EMF you can get, students? Yes, Sajid. Yeah, this is 125. This condition is given. It is given in problem. It is given. Given that IB. Yes. What is this back EMF you can get, friends? 400 minus 62.5 into 2. How much back EMF you can get? This is equal to how much you can get, friends? Yes, sir. Krishna Gandikota. Good evening. Welcome to the session. Yes, friends. This is how much? 387.5. We can get 387.5. Very good. Very good. 387. Then what the braking current it is given, students? You know this one? EB plus V by RA plus RB. RA plus RB. What the braking current? 125. What the EB? 387.5. What is the V, students? 400. RA is how much? 0.2 plus RB. Now from this you find the braking resistance. What the braking resistance we can get? RB plus 0.2 is how much? Then you find what is RB, students. Quick. Yeah, this is the problem on braking. Come on, students. Come on. All of you, very good evening. Welcome to the session. Yes, students. Can anybody answer this one? RB plus 0.2 is how much you can get, students? RB plus 0.2. How much you can get? Yes. Okay, you simplify this one. This is 387.5 plus 400 by 125. That is how much you can get, students? RB plus 0.5. 0.2. Come on. This 787.5 by 125. 787.5 by 125. Yeah, 6.6. Is it correct? I am doing this calculation. 787.5 by 125. 787.5. Yes, friends. 780 I am doing the calculation. 0.5 by 125. Yeah, you are getting 6.3. Then what is RB, students? 6.3 minus 0.2. This is how much you can get? 6.1 ohm. The braking resistance equal to 6.1 ohm resistance. The braking resistance equal to 6.1. Is it correct, students? Please concentrate, all of you. Is it correct? Yeah. 6.1 ohm. This is 387.5 plus 400 by 0.2 plus RB. RB equal to 6.1 ohm we can get. Yes. Which option is correct, students? Option A is correct. Yes, Saujanya. Yes, very good. Yes, 6.1. Yeah. The next question, it is a very simple question. Different, I told this concept today I am covering the different cases and testings. Different cases and testings. Yeah. Test. There's a 4-pole DC generator is running at 1500 RPM. The frequency of current in the armature winding is. The frequency of current in the armature winding is. Can anybody answer this one, friends? A 4-pole DC generator is running at 1500 RPM. The frequency of the current in the armature winding is. Yes. Given that it is a DC generator. But because given is DC generator, that's why it is frequency 0. Like that, don't take, sir. This is wrong. In armature, the induced EMF is AC. In any machine, in armature, the induced EMF is AC. The induced EMF is AC. Induced EMF is AC, students. Hence, current is also AC. Current is also AC. Current is also AC. Don't think. But after converting that using the commutator, then you can convert AC to DC. But within the armature coils, the induced EMF is AC, even though it is a DC generator. The armature EMF is AC. Very good. Very good, Gupta. Yes, very good, Saujanya. That's why what is F equal to N into P by 120? 1500 into, yes friends, number of poles is 4 pole by, yes. Yes friends, number of poles, this is 120. How much we can get? 50 Hz. Simple question. Next. Yes. Come on, students. The next question is displaying on the screen. This is the question based on the testing. Testing of induction machine. Sorry, testing of DC machines. Come on, students. Which of the following tests can be conducted on other than the shunt machines? Which of the following tests can be conducted on other than the shunt machines? Yes, means which of the following test is conducted on other than the shunt machines? Friends, this is the Swinburne's test. Swinburne's test is no load test. I think all of you know this one. No load test. This is mainly conducted for constant flux machines. You imagine what you remember that one, sir. What you done in your laboratory? Mainly conducted for constant flux machines. Constant flux machines. Which are the constant flux machines? Students, that is shunt motor, that is shunt machine and compound machine. For these machines, we can conduct the which one? Swinburne's test. This retardation test also no load test. This retardation test also no load test. Students, no load test. This is also no load test. What is the purpose of using retardation test, students? Retardation test is used to find which one, students? Retardation test is used to find which one, students? Come on. Retardation test is used to find which one, students? To find stray low losses. To find the stray losses. To find stray losses. In the case of DC machine, stray losses are nothing but a, yes friends, mechanical losses plus iron losses. These losses are called stray losses. In the case of DC machine, mechanical losses plus iron losses are called stray losses. In the case of DC machine, to find the stray losses, we can use this one. But in DC machines, which losses are called stray losses, students? If it is not visible here, writing separately. Yes, please concentrate. These stray losses are nothing but a, which one? Mechanical losses plus iron losses. This is iron, mechanical losses plus iron losses. Next, back-to-back test. Back-to-back test is which test, friends? Which test is called back-to-back test? Which test is called back-to-back test, friends? Hopkinson's test. Hopkinson's test. Which test is the back-to-back test? Hopkinson test. This Hopkinson test is conducted for conducted for shunt machine. Conducted for two similar shunt machines, and it requires two similar shunt machines. It requires two similar shunt machines. This you know. Two similar. This is one of the main drawback of Hopkinson test. Two similar shunt machines. Yes, friends. This retardation test also conducted for shunt machine. We can conduct for shunt machine. We can conduct for shunt machine. You also conduct for compound machine. Retardation test. Here, which of the following tests can be conducted on other than the shunt machines? Yes, field test. Field test is not conducted for shunt machines, but Swinburne's test and retardation test, these two are not conducted for series motor. Swinburne's test and retardation test not conducted for series motor. Why? If these are the no load tests. These are the no load tests. Series motor never run at no load conditions, students. That's why Swinburne's test and retardation test is not conducted for series motor. That's why for series motor specially we are using field test. This is used for series motor. Field test. This is conducted for the series motor or traction motors. Traction motors. Which of the following test is conducted for the traction motors? Which one, students? Field test. Which one? Yeah. Field test is conducted only for series motors. Okay, that point. Back-to-back test is conducted for shunt machines. This back-to-back test is also called Hopkinson test. It is conducted at full load condition. It is conducted at a full load condition. Okay, that point. The power requirement in the back-to-back test or Hopkinson test very less as compared to its rating. As compared to its rating. Okay, these points you know, students. But here the question is asked, which of the following tests can be conducted other than the shunt machine? That is a field test. Field test is conducted for series machines. Yes, friends. Is it okay? That's which option is correct? Option C is correct. Option C is correct. Next. Come on, students. In a DC motor running at 1000 RPM, the hysteresis and eddy current. This model is also important, already framed in gate exam. Yes, friends. In a DC motor running at 1000 RPM, the hysteresis and eddy current losses are 250 watts and 1000 watts respectively. If the flux remains constant, calculate the speed at which the total iron losses are halved. Calculate the speed at which total iron losses are halved. If the iron losses are reduced by 2, then what is the speed that you want to calculate? This model is also important. Then how to solve this model, students? Yes, Vidyasagar. Good evening. Welcome to the session. All of you welcome to the session, students. Yes, friends, all of you like the session and share the session. Who are the aspirants for GATE, ES and PSUs? These models of questions are more important. Yes, friends. Now tell. In DC motor, given that constant flux is constant. At constant flux operation, hysteresis loss are proportional to speed. That is WH equal to N. Eddy current loss are proportional to WH equal to AN, some constant. WH equal to AN. WE proportional to N square, eddy current. WE equal to BN square. Okay, this is. What the total iron losses, students? The total iron losses equal to hysteresis losses plus eddy current losses. Come on, students. Hysteresis losses plus eddy current losses. The total iron losses equal to hysteresis plus eddy current losses. This is how much, students? 100 plus 250. This how much? 350 watts. If iron losses is, if Wi2 equal to Wi by 2, that is 175 watts. Then what is the speed? What is the speed? Okay, this is the question asked. This is the, if Wi by 2, then what is the speed? We know this, students. What are the total iron losses? It is at flux equal to constant operation. Wi equal to AN plus Bn square. An plus Bn square. This is for flux equal to constant operation. Then I want to find A and B. For that use this one. WH equal to An. From this one, what is A, students? WH by N. How much hysteresis losses are given, students? Hysteresis losses equal 250. 250 by 1000. 250 by 1000. This how much you can get? 0.25. Next, WE equal to Bn square. WE equal to Bn square. Then what are the B, students? WE by N square. Yes, WE is how much, friends? How much eddy current loss are given? 100. 100 by 1000 into 1000. This is how much we can get. Two zeros are cancelled. Then how much? 0.0001. Is it correct, friends? Yes, this is B. Then Wi equal to 175. What is A? A equal to 0.25 plus. What is B, friends? 0.0001 N square. Then from this 0.0001 N square plus this is 0.25 N. Is correct this? Yes, friends. This is 0.25 N plus 0.0001 N square. Yeah, this is how much? Minus 0.25 N, so plus 0.25 N minus 175 equal to 0. Then solve for this N. What is N, friends? Minus B plus or minus. Minus 0.25 plus or minus square root of B square. B square is how much, students? B square 0.25 square minus 4AC. Minus into minus plus. This is 4A 0.001 into 175. Important for 2 marks question for gate exam. By 2A. 2 into 0.0001. Can anybody answer what is this value? Abhishek, it's not 0.001. I think 000. In denominator, we can get 4 zeros now. That's why 4 decimals. 0.0001. Is it correct, Abhishek? I think it is not 001. 0001. Is it correct? 0.000. Come on, friends. Can anybody answer? You can solve this one. Yeah, calculations also very fast you want to do. You know, even though you know the concept, you are very strong in the calculation, then we can easily crack any exam. How much we can get, students? This you simplify, this how much we can get. Come on, students. Come on. All of you try to simplify this one. Minus 0.25 plus or minus square root of 0.25 square. I think all are having the calculators. Yes. This how much you can get, students. Yes. Very good, Saujanya. We are getting 570 RPM. 570 RPM. Very good. Then which option is correct, students? Which option is correct? Yes. Option C is correct. Very good. Option C is correct. We are getting 570 RPM. Okay, like this we can solve. Very important model. Please concentrate. Very good, sir. 570 RPM we are getting. Which option is correct? Option C is correct. Yes. The next question is displaying on the screen. Can anybody answer this one, students? This is the question based on the brake test. Brake test. This is the question on the brake test. It's also called load test. Load test on shunt motor. Brake test or load test on shunt motor. Yes, friends. I think all are these calculation you already done in the laboratory. Already you done in the laboratory, students. I think all of you know this one. In shunt motor, you conducting the brake test. It is a load test. It is a brake test. We can conduct like this. Yes, friends. This is the shunt motor. This is a shunt motor. I think how to conduct the brake test on the shunt motor, all of you know. This is a practical circuit I am drawing. This is a variable resistance. Rheostat we can connect. Here we are giving the supply. Giving the supply. Yes, friends. Yeah, this how to conduct. All of you know this. Okay. This you know. We can make the some springs. We have the some spring loads. Spring loads. Okay. This is the spring loads. Yeah, this is S1. This is S2. Spring loads we have. Spring load. Okay, students. This is spring loads. We can apply the spring load. Yeah, this is the which test, friends? Brake test. We are conducting the brake test on DC shunt motor. Brake test on the shunt motor. Yeah. To find the efficiency. To find the efficiency. Yes, friends. Yeah, please come. Now, the tensions on the two sides of the brake are 2.9 kg, 0.17 kg. Let this is the 2.9 kg. This is the 0.17 kg. Now I want to find resultant weight S1 minus S2 I am calculating. Yes, friends. 2.9 minus 0.17. How much S1 minus S2 we can get, friends? Yeah, 2.9 minus 0.17. We can get 2.73 kg. Okay. But I want force. Yeah, I want force on the net force on the pulley. You find this one, friends. What is the net force on the pulley? Net force on the pulley. Weight, you know. Once you know the weight, how to calculate the net force on the pulley, students? How to calculate net force on the pulley? That is, you know W force you want means mg. That is S1 minus S2 into G. Yeah. What is S1 minus S2? You got 2.73, students. How much S1 minus S2 you got? 2.73 into 9.8. You multiply this, how much we can get, students? Yeah, 6.78 Newton meter we can get. Sorry, newtons we can get. This is a net force now. This we can get newtons. Is it okay, students? That is 6.78 Newton. Is it correct? S1 minus S2, 2.73. Is it 6.78? 26.78. It's a 26.78 Newtons. Is it correct, students? S1 minus S2 into G. Because I want the force, net force on the pulley. Yes. Next, what is the net torque? What is the net torque, students? I want net torque. This you know, force into radius. Force into radius. Direct formula also you can write, but separately I am doing force into radius. What is the force? 26.78 into what the radius? Drum radius is how much it is given, students? Yeah, drum radius is how much it is given. The radius of the drum is a brake drum. Yes, friends, how much it is given? 7 centimeter. Radius of the pulley. That is a brake drum or pulley. 7 centimeters. 7 centimeter means 7 by 100. I am converting into meters. Yeah, 26.78 into 7 by 100, students. What you can get? 1.8746 Newton meter. 1.8746 Newton meter. Is it okay, friends? Yeah, this is the net torque. What is the power output? Power output. The power output equal to, yes, P equal to 2 pi nt by 60. 2 pi nt by 60. 2 pi n is how much speed it is given, friends? Motor speed is how much? It is given is how much, friends? Come on. 1500 rpm. This is 1500 rpm. Yes. Torque is 1.8746 by 2 pi nt by 60. Not 600, it is a 60 by 60. This how much power output we can get? How much power output we can get, students? This is how much? Come on, students. Yes, Saujanya. How much power output? Yes, Amit, good evening. Welcome to the session. How much power output we can get, students? 2 pi into 1500 into 1.8746 by 60. Come on, students. Yes. Yes, friends. Yeah, 2, is it 290 or 294, Abhishek? Is it 290 or 294? Come on. 1.8746 into 1500 into 2 pi by 60. I got 294 watts. Yes. Very good. 294 watts. Then what is the efficiency, students? What is the efficiency? Efficiency equal to output by input. Output is 294. Output is 294. What is the input? Input is 2 amperes at a voltage of, students, 2 amperes at a voltage of 230 volts. 2 amperes at a voltage of 230 volts. That is 2 into 230. How much efficiency we can get? Then how much efficiency we can get, students? Yes. The percentage efficiency, can anybody answer? 294 by 2 into 230. Come on, students. Yes. How much efficiency you got? Now, this is equal to 63.9% we can get. Any doubt? 63.9% we can get. Yes. Then which option is correct, students? Which option is correct? 63.9% we are getting. Yeah, 64%. Option C is correct. Yes, friends. See, net force I calculated, then I calculate the torque. Or otherwise, you know, in the laboratory, in observation, you solve this. In record and observation, you know this formula. Directly also you can apply, students. How much torque is produced means S1 minus S2 into G into R. It is where R is the drum radius. Where R is the radius of the pulley. This formula directly write S1 minus S2 into G into R. Yeah, this is called torque. Once you know the torque, how to find the power output, that you know. Yes, friends. Yes. Now, this is the question on the brake test. The next question. It's very important, friends. Please concentrate. This is a question I am solving on the Hopkinson's test. Hopkinson's test. Hopkinson's test. This, you know, I told already, this Hopkinson's test is conducted on the two similar shunt missions. Two similar shunt missions. In a Hopkinson's test, on 220 volts 110 kilowatt generators, the circulating current is equal to the full load current. In addition, 90 amperes are taken from the supply. The efficiency of the each mission is that. Yes, friends. Very important. Its simple formula is there. Still now not asked in any competitive exam, but in future compulsory you can expect, students, the efficiency equal to square root of I1 by I1 plus I2. Very simple formula. Efficiency equal to square root of I1 by I1 plus I2. In the case of Hopkinson's test, where I1 is the current taken from the supply. Sorry, current, where I1 equal to current supplied or output current. Current supplied to the motor. Where I2 is the current taken from the supply. I2 is the current taken from the supply. Small current is taken from the supply. Yes, friends. Now, first I want to current supply to the motor means output current. That I want to calculate output current. Then, in order to find the output current, use this data, students. Then, how to find the output current? I2 equal to, sorry, it's I1. I want to calculate I1. What is I1, students? It is the 110 kilowatts. 110 into 10 cube by 220. Can anybody answer what is this current? This is the Hopkinson's test. Yes, 110 into 10 cube by 220. Can anybody answer how much we can get, students? 110 into 10 cube by 220. Abhishek, you given option B. Very good. For this question, option B is correct. Very good. Yeah, this is how much, students? 454.4 amperes. 454.4 amperes. Is it correct, students? 454.4 amperes. Then you substitute here efficiency equal to square root of 454.4 by 454.4 plus 90. This we can get, this how much we can get, students? 91.4%. 91.4%. This we can get 454 point. It's a 110. It's a 110. Are you getting 500? This one. Is it 500? Sorry. Yeah. This how much, students? This is it 500? Yes, it is a 500. Sorry. Then this is how much? Now what is the efficiency? Can anybody answer this one? Yeah, this is 500. 500 plus 90. Now answer the efficiency. What is you got? Yes, sorry for that. Yes, 500 by 500 plus 90. How much you got? Yes. Now tell the efficiency. Come on, students. Amit, you given option B. Now what is the efficiency? Are you getting 91% or different? Are you getting 91? Yeah, that is nearly equal to 91%. Yeah, option B is correct. Approximately. Yes, Amit. Next. One more question, students. This is also 5-star model. We can expect in competitive exam. We can expect. Please concentrate. In the Hopkinson's test on 2 DC missions, mission A has field current of 1.4 amperes and mission B has field current of 1.3 amperes. Which mission acts as a generator? Which mission acts as a generator? It's very simple, students. Always the field currents and the voltages are directly proportional. That means the induced EMF in mission A by the induced EMF in mission B is equal to field current in mission A by field current in mission B. These are directly proportional. Yes, friends. What is EA by EB? EA by EB equal to what is IFA? IFA is how much, students? The field current of mission A is 1.4 amperes. What is the field current of mission B? 1.3. Then EA equal to how many times of 1.4 by 1.3, students? How much we can get? 1.4 by 1.3. How much we can get? Yeah, this is EA by EA equal 1.4 by 1.3. Come on, students. How much you got? This 1 point, that is 1.077 EB. That means EA is greater than EB. EA is greater than EB means that is mission A supplying power to mission B. EA greater than EB. That is mission A supplying power to mission B. That's why mission A acts as which one, students? Mission A acts as a generator or motor. Now come on, students. Mission A acts as a generator. Now mission A is supplying. That's why it acts as a generator. This is the Hopkinson test. One is generator, another one is motor. It is a back-to-back test. It is a back-to-back test, students. Mission B acts as a, because mission B is taking the power. That's why it acts as a motor. Mission A acts as a generator. Mission B acts as a motor. Because EA greater than EB. EA equal to 1.077 times of EB. That's why mission A acts as a supplying the power to mission B. Mission A acts as a generator. Mission B acts as a motor. Very good. Very good. Clear, sir? Understand? Very important model we can expect in competitive exam. We can expect in competitive exam. Yes. Which acts as a generator? Mention here acts as a generator. Clear? Next. One of the main advantages of Swinburne's test is, come on students, one of the main advantages of Swinburne's test is that, can anybody answer this one? Which is the main advantage of Swinburne's test? Which is the main advantage of Swinburne's test? Is applicable to both shunt and compound motors, needs one running test, is very economical and convenient, ignores any change in iron loss. It is a more economical test. It is, yes friends, it is the more economical test. Which is the more economical test? Yes, Swinburne's test is the more economical test. Swinburne's test is the more economical. Yeah, it is main advantage I am asking. It is applicable to shunt and compound motor. Yes, it is applicable. Shunt motor it is applicable, but it is not an advantage. Remaining test also there, which applicable for both shunt and compound motors. Remaining test also there. But here I am asking main advantage. The main advantage of Swinburne's test is it is the more economical test. Very economical test. That's why not option A. Option C is the correct answer. Yes, students, you are telling that it is applicable for shunt and compound. Yes, but which is the advantage? It is applicable for shunt and compound. Then what is that advantage? There is remaining tests also there, which applicable for both shunt and compound motors. But this one is even brake test is there. Brake test is also you can apply for shunt and compound motors. Sir. That's understand. But which is the more advantage here? Yeah, economical is and convenient. Yeah, this is the consideration. Very important. Please concentrate. Now, students, to answer any questions, here I am giving one note. Please concentrate. With respect to accuracy point of view, which is the more accurate test? Which is the more accurate test, students? With respect to accuracy point of view, which is the more accurate test? Can anybody answer? Which is the more accurate test among all the tests? Field test is the more accurate test. Field test. The next one is, which is the more accurate test, students? Hopkinson's test. Hopkinson's test. To answer the different questions, I am giving this summary. Hopkinson's test is more accurate test. Next, which one is the more accurate test, students? Yes. Next, which one? Retardation test. Retardation test. Retardation test. Least accuracy is Swinburne's test. Least accuracy is Swinburne's test. That is, field test is more accurate. Next, Hopkinson test. Next, retardation test. Next, Swinburne's test. With respect to, yes friends, economy, that is, which is a less cost. With respect to order of economy. With respect to economy point of view. Economy point of view. Which is, with respect, which is the more economical? Which is the more economical, students? Swinburne's is more economical. Next, which is the more economical, students? Retardation. Next, which is the more economical? Hopkins. Which is the least economical, students? Field test is the least economical. This is more economical, means less cost, more economy. That is less cost. Among all the tests, it takes the less cost to conduct. This is high cost. High cost. That is a costly method. This is the costly method of conducting the test. Costly method of conducting the test. To answer different questions, this I am giving this observation. A field test is the costly method. Field test is a costly method. Yes. Yes. But it changes. Retardation test. Next one is retardation. Hopkinson test is somewhat cost as compared to retardation test. Is it okay, students? Is it okay? Understand? To answer different models of questions. Here accuracy point of view, it is economy point of view. Which is more economical? Swinburne's. Which is the least economical? Field test. Clear, students? Next. The main disadvantage of Hopkinson's test for finding efficiency of shunt DC motor is that. Can anybody answer? Quick students. What is the main disadvantage of Hopkinson's test for finding efficiency of DC shunt motor is that it. Yes friends. What is the main disadvantage? What is the main disadvantage of Hopkinson's test? One of the main disadvantages is it is a somewhat costly. Okay, that is one. But it is not there in the options. But which is it requires two identical shunt machines. It requires two identical that I told already. In Hopkinson's test compulsory, it requires the two identical shunt machines. Practically, exactly similar missions is difficult. That's the reason why this is somewhat difficult in this test. Very good, Amit. Very good, Abhishek. Yes. Next. The usual test for determining the efficiency of traction motors. The usual test for determining the efficiency of traction motor. Come on, student. The usual test for determining the efficiency of traction motor. Traction motors are nothing but which motor, students? Series motors. Series motors. Yes, we can conduct which test? Field test we can conduct. For series motors, we are using which test, friends? Sir, for determining the efficiency of a traction motor is a field test, not a Swinburne's test. Don't apply Swinburne's test to traction motors. Don't apply Swinburne's test to traction motors because Swinburne's test is a no-load test. Don't apply no-load test to series missions. Don't apply the no-load test to series motors. Yes, very good, very good, very good. Field test, sir. Field test. Please concentrate. Field test is only applied for series missions. Series motors. Next. One more question, students. Quick. These are the different special cases. I told already this session is completely based on the test and special cases also. This is the special cases in the DC missions. Can anybody answer this one? A 6-pole lap connected DC generator has armature resistance of 0.06 ohms. If it is reconnected in wave, then find the armature resistance. Come on, students. A 6-pole lap connected DC generator has armature resistance. It's one method, two methods I am explaining. Whatever the method you convert, that method you follow. This method one I am explaining, sir. A 6-pole lap connected DC generator. In lap connection, lap number of poles equal to 6. Then in lap connection, A equal to P, that equal to 6. Then this is 6 parallel paths. 6 parallel paths. How many parallel paths, friends? 6 parallel paths. Totally how many parallel paths? 6 parallel paths. Okay. Now, what is RA given? Armature resistance is equal to R path by 6. This is how much, friends? 0.06. Then what is the path resistance? 0.36 ohms. Path resistance. Now it is reconnected as a wave winding. Wave winding means 2 parallel paths. Wave winding is very good, Amit. Wave winding is 2 parallel paths. 2 parallel paths means you convert it like this. 2 parallel paths. Yes, friends. Wave winding means 2 parallel paths. Please concentrate. Now, this 6 is converted into 2 parallel path means each path is 3 conductors. Each path is 3 conductors. 2 parallel. This is how much, friends? 0.36. 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 This is how much? Each path is 0.36. This is 0.36. Then what is the armature resistance? What is the armature resistance? 0.36, 0.36, 0.36. This is how much, friends? 1.08. Then 1.08 by 2. 1.08 by 2 means 0.54 ohms. That's why what is the armature resistance in wave winding? 0.54 ohms. Okay. Armature resistance in wave winding. This armature resistance in lap winding. This armature resistance in wave winding. Is okay, friends? Okay, like this we can solve. This is one way to solve this question. The another method is, second method also I am giving. This is a formula based. Second method, friends. Then you know this RAW by Yes, I want yeah, RAW by RAL. That is resistance in wave winding equal to resistance in lap winding, students. AL by AW whole square. AL by AW whole square. How many number of parallel paths in lap winding? 6. This by 2. 6 by 2 whole square. This is how much, friends? 9. Then what is, it is the method 2. I am giving method 2. Whatever the method you convenient, that method you follow. Yeah. RAW equal to how much, students? 9 into RAL. What is the resistance in lap winding? 0.6. 0.06. This is how much we can get? 0.54 ohms. Yeah, this also second. This is the second. Whatever the method you convenient, that method you follow. Yes, friends. Use this formula directly or according to concept also we can solve. According to concept also we can solve. This each path resistance I am calculated here. Is it clear, friends? Next one. Come on, friends. Come on. This is a special case also. This also directly we are not applying formulas here. This is special cases. A 4-pole DC generator has 100 tons. 100 tons. Come on, friends. 100 tons. EMF per turn equal 10 volts. I path equal 10 ampere. If it is connected in lap, connected in wave, find the generated EMF, armature current, generated power. Yeah, first one. A question I am solving for lap connection. For lap connection. Students, what is the generated power? The generated power is equal to EMF per turn. This is a formula you can use. EMF per turn into, yes, friends. How to find the generated EMF? EMF per turn into, yes, friends. Tons per path. Tons per path. Turn by path. Now, what is the generated EMF, students? Then what is the EMF per turn? EMF per turn is 10. How many number of turns it is given? How many number of turns it is given? Yes, friends. How many number of turns it is given? Come on, friends. It is 100 tons. 100 tons. For lap winding, A equal to P, that equal to 4. How many pass? 4 pass. How much you can get? 250 volts. This is a generated EMF. Next, armature current. Armature current means, you know this one, friends. IA equal to I path. I path by, sorry. You want armature current. IA equal to I path into 4. I path into A. How many number of parallel paths? Path current is how much? 10. 10 into 4. How much? 40 amperes. Next, what is the generated power? EZ into IA. Generated power equal to EZ into IA. That is 250 into 40. How much we can get, friends? How much we can get this? 10 kilowatts. Generated power equal to 10 kilowatts. Very good. Generated power equal to 10. This is for which one? Lap connected. Now I want to solve on the wave connected. For wave connected. For wave connected, friends. Now can anybody answer for wave connection? For wave connection, A equal to 2. Then what is the generated EMF? What is the generated EMF? Come on, friends. What is the generated EMF for wave connection? EMF per turn into tons per path. Tons by path. Yes, generated EMF equal to, yes, friends. What is EMF? 10 by, yes, 10 into number of tons. How many tons it is given, friends? Number of tons. How many tons it is given? How many number of tons it is given? Yeah, 100 tons. 100 tons. How many parallel paths? 2 paths. How much? 500 volts. Yes, A equal to, this is generated EMF. What is the armature current? I path into A. Path current is how much? Path current is how much, friends? How much path current it is given? 10 amperes. 10 amperes. 10 into 2, 20 amperes. Very good. What is the generated power? What is the generated power? P generated, students. P generated. EC into IC. How much we can get? That is 500 into 20. How much we can get? 10 kilowatts. Is that 10 kilowatts? Very good. Now, what is the observation here, students? Can anybody tell what is the observation here? From this very important observation, same mission can be connected as a lap and wave. Same mission can be connected as a lap and wave. Yes, friends. Then in lap connection, low voltage, high current. Low voltage, high current. But in wave connection, high voltage, low current. High voltage, yes, friends. Please concentrate. High voltage, low current. That is one observation. But same mission can be connected as a lap and wave. There is no change in power rating. What is the power rating? 10 kilowatts. What is the power output? 10 kilowatts. What is the power output? 10 kilowatts. Understand, students? That means here I am giving observation. Very important observation here. Yes, friends. Lap connection is used for lap connected winding is used for high voltage. Lap connected winding is used for high current, low voltage. Low voltage. What about the wave connection, students? Wave connected winding is used for high voltage and low current application. Low current. Yeah, this is the observation. But same mission can be connected as a lap and wave. Same mission can be connected as a lap and wave. What are the power, students? Power rating. The generated power equal to constant. There is no change. The generated power equal to constant. There is no change, students. Okay. One more note I am giving here. Please concentrate. That's why if in terms of voltages, EL by EW is equal to AW by AM. Inversely proportional. Yes, friends. EL by EW equal to 8. Because here in lap connection, there is a more number of parallel paths. But induced EMF is less. Generated EMF is less. In wave connection, number of parallel paths is 2 only. But more generated EMF. That's why induced EMF and number of parallel paths is inversely proportional. That is, EC is proportional to 1 by A. If the number of parallel paths are more, the generated EMF is less. If the number of parallel paths is more, Yes, what will be taking tomorrow? Yes, tomorrow, yes. Abhishek, I am starting the continuation of series, not starting. After 3 or 4 days, I will start the continuation of series. Next mission, I will start. But tomorrow, I am taking for Hall and HPCL point of view, I am taking the measurements. Most expected models of questions for Hall and HPCL point of view. At 4 o'clock, I am taking that section, students. Okay, tomorrow. Measurement session I am taking. We will solve the nearly 40 plus questions in measurements for Hall and HPCL point of view. Yes, friends. Then this is for what about the number of parallel paths and current, students? What is the number of parallel paths and current? Then IL by IW. More number of parallel paths, more current. That's why AL by AW. IL by IW equal to, this is a directly proportional. That is, I is proportional to A. IL by IW equal to AL by AW. This observation is also important. Clear, friends? Is it okay? Okay. This is about different models of questions that you can solve. For example, can anybody answer this one, friends? Last one, just 5 minutes, friends. Please concentrate. The ratio of generated EMF in wave and lap. Can anybody answer this question? Yes, students. Come on. The ratio of generated EMF in wave and lap. EW by EL. What is EW by EL, friends? AL by AW. It is asked wave and lap. EW by EL equal to AL by AW. In lap connection, how many number of parallel paths? 8. In wave connection, 8 by 2. That is 4:1. 4:1. Is it okay, friends? EW by EL equal to AL by AW, 8 by 2, that equal to 4:1. Next, Ratio of armature current in lap and wave winding is armature current. Students, lap and wave winding. Lap and wave winding. IL by IW is equal to AL by AW. Is it correct, students? AL by AW. AL by AW. Is it correct, students? AL by AW means 8 by 2. That is 4:1. 4:1. 4:1. Yes. Abhishek, which is 2? 8 by 2. Yeah. 4:1. Now, what the power? Power in lap and wave. I told already. Power remains constant. Power remains constant means 1:1. Is it correct, students? Power remains constant means 1:1. It is a 1:1. Power remains constant means it is 1:1. Clear? Yes. Yes, friends. Yeah, like that we can solve any question. Can anybody answer this one? A DC shunt motor, direction of rotation is reversed by. A DC shunt motor, the direction of rotation is reversed by reversing which one, friends? We know that always direction depends on the torque. T is proportional to pi Ia. T is proportional to pi Ia. Yes, friends. If pi is reversed, or Ia is reversed, then torque is reversed. If pi is reversed or Ia is reversed, torque is reversed. Then direction is reversed. Yes, friends. Then direction is reversed. Then which option is correct, friends? Which option is correct? Either field terminals or armature terminals, but not both at a time. Very good. Option D is correct. Either field terminals or armature terminals, but not both at a time. Yes. Friends, this is the last question I want to solve. Remaining, I will give the assignment. A DC shunt motor running at rated speed. Very important, friends. These are also special cases. Remaining special cases, I am giving assignment. If you have any doubts, then you can share your doubts in my Telegram channel. This question I am solving. A DC shunt motor running at rated speed. Come on, students. A DC shunt motor running at rated speed. If shunt field winding condition is rated speed, this is important. Condition is rated speed. If the shunt field winding is open circuited, then the motor will. Given is which motor, friends? Shunt motor. Please concentrate. Given is shunt motor. Come on, friends. Yeah, this is the supply. Motor means we are giving the supply. Given is shunt motor. These are special cases. Given is shunt motor. This is the shunt field winding. This is a back EMF. This is IA. And this is ISH. Yeah, this is I. Now tell us, friends. What the first case it is given? We know this one. N is proportional to EB by pi. N is proportional to EB. And T is proportional to pi IA. Okay. Running at rated speed. If it is not talking about the load, all these. If shunt field winding is open circuited, then motor will. If shunt field winding is open circuited, friends. In the first case, if the shunt field winding is open circuited, pi equal to 0. Pi equal to 0 means N is proportional to EB by 0. EB by 0 means infinity. That is, will run at then motor will run at a dangerously high speed. Dangerously high speed. Very good, Amit. Very good. Yes, friends. If the shunt field winding is short circuited, then the motor will. See the second case, students. Shunt field winding is short circuited. Shunt field is short circuited means this one. If the shunt field is short circuited means this total current is diverted like this. Then what is this one? In this case, shunt field winding is short circuited means Ia equal to 0. If Ia equal to 0, torque is 0, the motor will stop. Students, shunt field winding is short circuited. Always current is diverted through this path. Then there is no current, armature current. When the armature current is zero, the motor will stop. Clear, students? Understand or not? Next, shunt. If the shunt, not shunt, yes. Next, students. If the armature winding is short circuited, if the armature winding is short circuited, students. If the armature winding is short circuited means this one. If the armature winding is short circuited, what is IA? In this case also, armature is short circuited. There is no current through armature. Once there is no current through armature, students, once there is no current through armature, what the motor will? Can anybody answer this one? If the armature current is short circuited, can anybody answer what the motor will? Stops. Because there is no torque. Current is not passing through armature. Current is not passing through armature. The motor will stop. Yes. If the armature winding is open circuited, if the armature winding is open circuited, here also IA equal to 0, the motor will stop. Students, it's very simple. If the field flux is 0, motor run dangerously high speed. If the armature current is 0, please, that point remember. Concentrate on the armature current is 0. There is no current through armature. Motor will stop. No need to think about the flux. No need to think about the flux. No need to think about the flux. Because there is no current. Where is the torque? Where is the running, sir? Where is the running? That's why the motor will stop. Clear? Yeah, this is the condition with assumption of rated speed. With assumption of rated speed. Yes. All these I am giving for assignment. With this knowledge, you try to answer these questions. You try to answer these questions, students. You try to answer these questions. Okay? And if you have any doubts, share your doubts in my Telegram channel. This also I am giving for assignment. One is series motor, another is for cumulative compound motor. Cumulative compound motor. This is a special case, students. This also special case. I am giving the assignment. If you have any doubt, it is connected to bus bar. If it is prime mover is removed, in the case of shunt generator, if the prime mover is removed, it acts as a motor. It is a shunt motor. It acts as a motor, rotate in the same direction. Rotate in the same direction. Same case, in the case of series generator, if the series generator prime mover is removed, it acts as a motor, but it rotates in opposite direction because both field and armature is reversed. Both field and armature is reversed. Same case, if it is a DC cumulative compound generator, DC cumulative compound generator, students, if you want anybody interested taking the students screenshot, this question I am giving. Practice purpose, all this I am giving. Please concentrate. This 18th one assignment. Do this one. Next. This 19th one also assignment. Do this one. Yes, students. This the 20th one is also assignment. Series generator supplying power to DC bus bar. If the prime mover is removed, it acts as a motor. But both armature current and field current is reversed. That's why it rotates in opposite direction. For shunt motor, same direction motor. But also it is a series motor, but opposite direction. Opposite direction, students. The next one, a cumulative compound generator connected to bus bar. If the prime mover is fails, it acts as a motor. It acts as a motor. But which motor? Differential compound motor. Differential compound motor rotate in the same direction. It is a differential compound motor. Students, analyze by your own. If you have any doubts, you can share your doubts in my Telegram channel. Yes, friends, this is the question based on the dynamic braking. You try to answer this one. The question based on the dynamic braking. This is the question based on the plug. This is the question based on the starters. Starter, students. You try to answer this one. If you have any doubts, share your doubts in my Telegram channel. This is the question based on the plug-in. I already solved. At starting, I given this type of model. Please try to answer this question. Yes, friends. This is the question based on the retardation test. Retardation test. Retardation test. Yeah, these are the different models of question for today concept. Thank you very much, friends. All of you, thank you. Okay, Abhishek. Whatever the problems are not discussed, I try to take the questions. Okay, I try to solve the questions. And you solve by your own. If you have any doubts, please share your doubts in my Telegram channel. I will give the detailed solution also. Yes, friends. Thank you very much. This is my Telegram channel. Who are not joined still now, you please join this channel for more updates about my lectures. If you have any doubts, clarification, then share your doubts. This is one announcement, students. There is a bar 2021 boost of course is started. Boost of course enrollment is started, students. For more information, contact this number. This one more announcement, students. There is a flat 50% off on Gradeup Super Mission Possible. You please concentrate, students. This is our Mega Mark Challenge July schedule. Yes, this is Gradeup Super, students who are the aspirants for GATE, ESC and PSUs for structured course. Then subscribe for Gradeup Super, students. Yes, friend, thank you very much. This is about today's session. Thank you very much. I am ending the session, students. Thank you all of you. Thank you, students.